Hello students, I know you're missing my presence in class, but at least you get to hear my wonderful golden voice. Let me review conversions, kind of what we've learned so far. So we've got our conversion diagram here. It tells us how to convert between different units, right? So if we start with grams of one chemical and we want to get to volume of a different chemical, we'd have to go moles A, moles B to volume B. So what are some important things to keep in mind about this? I think one important thing to keep in mind that people forget sometimes is that A, oh that's very small, A and B just are used to represent different chemicals. So what do I mean? A is the first chemical if at some point you convert to a different chemical, we call it B. So the only reason that we're using A and B is because there's thousands of different chemicals. So if we tried to put them all in a chart, it'd be insanely enormous and in like more than 2 dimensions. So it's too difficult. Another thing we just learned that it's worth reminding people of is that when you use the chemical equation, you're making a mole ratio from the coefficients. That's something to remember. Molar mass you get from the periodic table. And then the volume 1 mole at 20.4 liters only at STP, and this 6.02 times 10^23 is sometimes called Avogadro's number. Alright, so you won't have this on the test, but make sure you're comfortable doing all these conversions using it, and then at some point you'll have to, get yourself off of it. Okay, so when we're solving, a standard 6A problem, this unit 6, first things we always do is we want to annotate the problem to figure out what we are given and start with. So that's the first thing. Next thing we want to do is plan it out. So are you going mole A to what? Like what's your conversion? Like what's your steps, all right? And then you want to start with your given and use the correct conversion factors. And remember, with these conversion factors, the unit you come from goes on the bottom to cancel, and the unit you go to goes on the top. Okay, so let me give you some examples of this. Let's do 2 examples. I'm going to do them for you. Follow along, pause as you need to, replay. You don't want to your goal is not just to write this down. Your goal is to actually understand this. Alright, so here's the first one. We're going to use this reaction that we were using last time above propane. This is propane. So next time you're grilling, you can be like, hey, we're using C3H8 to make hamburgers. Delicious. And people will be like, you weird. Okay, plus oxygen. So we need 1 of these, 5 of these, and we create 3 CO2s and 4 H2Os. Alright, so it says how many moles of carbon dioxide are produced from burning 22 grams of propane, which I know is the C3H8. So if I go back to my steps, first thing I need to do is annotate the problem. So here it's looking for moles of carbon dioxide, and it's giving me grams of propane. Next thing I need to do is plan it out. So if I'm starting with grams of propane, that means I'm starting at mass A. So I know I can put mass A right here. And then if I'm going to moles of carbon dioxide, well, carbon dioxide is a different chemical, so then propane will be A, and carbon dioxide will be B. So I'm going to mole B. Mole B. And if I look at my diagram, to go mass A to mole B, I have to go through mole A. So I go mass A to mole A to mole B. So I start with my 22 grams of propane, C3H8. I'm going to do a conversion factor. I know that gram C3H8 goes on the bottom to cancel. I'm going to mole A, so I know mole goes on the top, and I know A is my propane, so moles C3H8. Now I can't remember, so I'm going to look. To go mass A to mole A, I use the molar mass from the periodic table. So I don't have a periodic table pulled up on my computer, but you can look and you can see that carbon has a molar mass of 12. There are 3 of them, so I times 3. And hydrogen has a molar mass of 1, and there's 8, so times 8. Alright, so I get 36 plus 8 gives me 44 grams per mole. So that means in 1 mole there are 44 grams. So the grams cancels out and gives me half a mole, or 0.5 moles, of C3H8. Okay, so that's my first conversion. Now I'm going to do my next one. Alright, so here I'll do this one color-coded. So this one's in red. So I do 0.5 moles of C3H8. I want moles of C3H8 on the bottom, since it has to cancel. I'm going to mole B, so I know a mole goes on the top, and B was carbon dioxide. Good idea to annotate the problem with what your A and B is. It might help save you some confusion. So I put carbon dioxide here, and then, oh boy, let's go back to the diagram. What is it? Mole A to mole B. I'm going to use my chemical formula and my coefficients. Well, actually my chemical equation here, because we're doing a reaction. Chemical formula would be just if you were inside of a chemical. Like how many H's in H2O. That would be chemical formula. Alright, ask me about that on Friday if you need more clarification about what I just said. Okay, so there are 3 CO2s when every 1 propane burns. So this cancels out and we get 1.5 moles of CO2. Alright, so if you want to really be impressive, you can write in a sentence. You can say 1.5 moles of CO2 are produced when 22 grams of propane burns. Because that's basically what we just calculated. We started with our 22 grams. It's equivalent to 1.5 moles CO2, so that's what we're producing. Let's look at this next one. Alright. So same reaction, different problem. Assuming STP, that immediately makes me think of gases. What volume of oxygen is needed to produce 66 grams of carbon dioxide? So first thing I do, I never went back to this for this, but we did do this. We started with our given and we used the conversion factors to cancel all that. We want to annotate the problem. Okay, I already annotated a little, but I'm going to say what is a question word, so what volume of oxygen, that's what I'm looking for. And we're starting with 66 grams of carbon dioxide. So I'm starting with mass of carbon dioxide, which is A, so I'll put an A right there. And I'm going to volume of oxygen, so volume. And oxygen's different than carbon dioxide, so that means this is a different chemical, that's B, so volume B. So to go mass A to volume B, I have to go to mole A, mole B, and then volume B. So mass A to mole A to mole B to volume B. Okay, so let's go. 66 grams of carbon dioxide. Gram CO2 goes on the bottom to cancel. Moles of A, which is CO2, goes on the top. Carbon has a mass of 12. We use molar mass for mass to moles. There's only 1 plus oxygen as 16 times 2. Add it all together, you get 44. Again, interestingly, as the molar mass. So it's 1 over 44 grams CO2. So you do your math, you get 1.5 moles of CO2. And then we're going to do our next step here. So we go 1.5 moles CO2. We want to get rid of the mole CO2, so we put that on bottom. We want to go to mole B, so I put mole, and B is oxygen, so moles of O2. Here I'm going to use my chemical equation, so there are 5 O2s needed for every 3 CO2s made. Right? So I do my math, and you get 2.5 moles of O2. Right? Divide this by 3 gives you 0.5, then multiply, you get 2.5. I just did that in my head, sorry if that was too quick. Alright, and then lastly, we need to go mole B to volume B, so I do my 2.5 moles of O2. I want to get rid of moles of O2, so I put that on the bottom. I'm going to volume, which is liters, and it's still B, so it's O2. And remember, to go mole to volume, you use 22.4 liters only at STP, but fortunately, it said it was at STP right here. So that means there are 22.4 liters of oxygen in 1 mole. Alright, so you do your math, which you can do you know, on paper, or you can be lame like me and get a calculator. Except I'm wasting time because my button on my keyboard's not working. Alright, so 2.5 times 22.4 gives me 56. Look, it would have worked out really nice anyway. 56 liters of O2. So there's my answer. And I can put in a sentence. I can say that in order to produce 66 grams of CO2, oh, that should be 66. It's still wrong. There we go. 6 grams of CO2, you would need 56 liters of O2 at STP. Alright, so there we go. So that's your overview. So now you're going to work on your guided practice, which is going to start in your notes on page 6, right here. Alright? If there's anything you need to go back and re-watch from this video, make sure you do that before moving on.